everybody. So if you came to the previous webinar, you had more than enough pep talks. So today is going to be, for better or worse, just looking at screens and trying to see how it works in practice. So first, we're going to install Python on your computer, assuming you have no Python whatsoever on your computer. The second thing is we're going to look at UK government real estate data, and we will briefly discuss that. The third step is we will import data into Pandas. We are, do like very simple manipulations with it to get just a basic feel of what is going on. That would be the content of our webinar. As you are watching me sort of the commands and sort of interpreting and explaining the commands, please don't feel stressed, because at the end of the webinar, I will put all the commands onto a text file and let Sonia have it, so you can have absolutely everything, so you can extract maximum use from this webinar. You will know how to install the software, you will know the source of free data, and therefore you can download this data, and then you will have the commands, and then when you see the commands, you would be able to do sort of small modifications to them, and this is how you learn. So you don't learn from writing from scratch, you learn by modifying existing things. Okay, so this makes the task manageable. Righto, so to download Python, so we go to this site, www.anaconda.com download. Does everyone, can you see this? Is this what came up? Yes. So you scroll down, it's a free download, and then you click download. So my demo assumes quite a vanilla sort of Windows machine. If you have something else, if you have Mac, and or another operating system, you know that, you pretty much know what to do. So you're used to being sort of, looking up what's compatible with your operating system. You click download, and the file downloads onto your computer. Now, I have to warn you, it's a 900 megabyte file. Now, the first question you might have, do we need to download a 900 megabyte file in order to install Python? Hear me out on this one. No, you don't. But if you are new to Python, then in order to hang on to your sanity until you can understand how the system works, I strongly advise you to download Anaconda and install Anaconda. So later on, when you are more experienced, when you have come to terms with how the system works, you will know what to modify for your own convenience. If you start modifying things randomly before you understand how the entire sort of workflow works, you will just give up, basically, because there are too many options involved. I suggest to go the default route now. So the 900 megabyte file downloads, you double click it and you install it as you do any kind of normal Windows software. At one point, a box appears and it says the recommended settings are as follows. Please use the recommended settings that come with Anaconda. So after you have installed Anaconda, you will go on your computer. So and on the computer, you will see something called Anaconda Navigator. So there would be a window that looks like this. Okay, all sorts of packages and whatnot that come with Anaconda. Out of this, you require this one, Spyder. Yeah. And then you click that to launch it. After you do this, you will be looking at this screen. One moment. 1 second. Come on, Zoom today. Sorry, sometimes Zoom is taking its sweet time.
It's okay, we have time.
Yeah, sorry. Right. Can everyone see sort of a dark looking screen?
Yes.
Yeah. Okay. So you see in the upper left corner, Spyder. So Spyder is what's known as an integrated development environment. It's a piece of software put together to make it easier for you to organize writing Python code. Now, what needs organizing and what doesn't need organizing, you will gradually understand as you understand more and more what is going on. Right now, we will speak about the obvious threefold sort of division of this window we're looking at. So on the left, you see a large window. This is the editor window. It's used for writing sort of scripts, complete pieces of software. Today, we're not going to be using the editor window because today our goal is to be as interactive as possible. So you can understand that gods don't come down and write Python, and this is a very straightforward thing. So this window, the lower right-hand corner, is interactive Python. So IPython, yeah. Here, an analogy with a natural language is appropriate. There are people, when they are trying to learn a language, they go to grammar books and they try to generate phrases based on grammar without knowing anything about the language. Usually, that's the most difficult way forward, and it takes the longest time before you sound like a native speaker, if ever. Usually, people just give up, I'm sorry to say. And then there is another type who buys a phrase book. So they look up bravely phrases in that phrase book. And imagine, let's say you don't speak English and you have a phrase. Would you please bring me a cup of coffee? So you don't understand how the phrase is built, but you know the outcome of the phrase. You know that if you go to a coffee shop and you read off from your phrase book this, usually a cup of coffee would appear at some point. The native speaker might say, dippy, 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 something that you don't understand, but there is a good chance that you will end up with a cup of coffee after that. Now, I don't advocate either of the extremes, because people who use just the phrasebook approach, they never end up understanding what is going on. I suggest going from both ends, some grammar, some phrasebook. Yeah, so and at some point, these two approaches will meet. But I strongly suggest try starting from phrasebook, in the case of Python especially. So interactive Python, you might say it's a sort of phrasebook. So you say something to Python and the system immediately responds to you. And even in the future, once you become extremely advanced, you never give up on interactive Python because, on the console window, because it allows you to test out ideas, work out what works and what doesn't work, and what works, you just put it in your, main script. So that's the console window. And here above the console window, so this is the upper right corner, yeah, we have an interesting one. So it's, look at this tabs underneath: help, variable explorer, plots, and files. Variable explorer is by far the most useful part of it, because as you write software, you will invariably working with variables. You would invariably saying, okay, create this data frame, create this string, and these variables would have certain values. And this would allow you to track down what variables are in place, what values they have at the moment. So I highly, highly, highly recommend the Variable Explorer to you. Plots is when you try to create graphics, so basically plot XY, in Python, plots appear here. Okay, so it's of mild use. No, files. It shows you sort of a small piece of the most ordinary Windows file system. Example, in this particular case, Spyder defaults to your user directory. So if you're a Windows user, you know that this is your C drive, the installation drive of your operating system. the users, and this is your username. So my username happens to be IMG. If your username is Paul, then it's going to be Paul here. Now, for the purposes of our webinar, I have created on the C drive a folder called sample data. Okay, so you on your C drive, you may create, I don't know, any other name, Bob. In this case, whatever takes place, whatever I show here would be saved in this Bob directory. So that's that's as far as the basic default view of this window go. So the more advanced you become, the more you will learn about ways of optimizing this window, like making it look the way it's convenient for you. But as you are a beginner, part of the things you are learning is what is convenient for you, right? So something that you can start with. That's what we're doing today. Okay, so that's the discourse on the Spyder window. Now, data. So we need some data to feed to Python to get it to do stuff for us. Let's see. So here, this is HM land registry. And it very conveniently has a large range of data. Let me talk about what is paid, what is free, because you want to know the legal implication of what you are agreeing to, and under what conditions the HM land registry gives you this data to use. So there are three permission settings for use of the data. If you're a commercial environment and if you're building an application and you are going to make money basically from using this data, then it's a paid, you must pay for data. Or if you're a commercial environment that thinks that you can build something that to make money from this data, but occasionally the HM land registry grants you free use of data under sort of exploratory license. So neither of this applies to us. What applies to us is the direct use license, which is absolutely free, which is given to you as an individual. For example, now you are a student trying to learn how to manipulate data with Python. So you would sign up, you would create an account with HM land registry. You need to supply to them personal information because they check that you are who you say you are. So they ask for your address, for your credit card, not for the purposes of paying. They need it to verify your identity. Because this is rather sensitive data. I mean, if you see it, you will realize that you yourself wouldn't want it to be given just to anyone. So once you've come past that point, let's have a look at the data we are going to be using in this webinar. So I have chosen the price paid data. So property gets bought and sold, and these transactions, the vast majority of these transactions get registered with the government. And it gives us enough room to play with our Python exploration. So here's the price based data, and there are different kinds of it. I mean, like, for example, you can get monthly CSVs. I mean, they're all CSVs. So text file CSV, so very easy, just right click and download. Once you have the permission, you just right click and download what you need. There is yearly information, and then there is this great mammoth of it's a 4.3 gigabyte CSV showing all price paid transactions from 1995 until last month. So we will be using this one. We'll just take 2021, complete yearly data. It says 110 megabytes. That's not true. It's 210 megabytes. And we've downloaded it. I mean, I've downloaded it for the purposes of this webinar and saved it on my computer. It's in 1 second. So if we go back into the Spyder screen, you will see in sample data, there it is, 200 whatever CSV file, and I called it pp-2021. Okay, so this is what we received with the HMLN registry. And let's just go back and see what sort of columns are involved. Okay, so our data is organized as follows. So the transaction ID number, this is just their internal administration, price paid, date of transfer, postcode, property type, like various types of properties that have changed hands, old or new, duration, etc., and you know, an extensive information about the address. Okay, right. So now we go back to our Python and hopefully stay there for a long time, because this window switching on Zoom is something they need to improve. Okay, right. Step number 1. Now we have a CSV file sitting somewhere in our Windows system, and we have Python. First, we need to import the CSV into Python somehow in order to work with it. And we do it with the following command. So, oops, sorry. Moment. Okay. So before I run it, note, by the way, how we use this console, because there are some useful things, useful little tidbits of how you interact with this. So you see, I, you know, either copy paste it or you type it in. So the first line is import pandas as PD. Pandas is the package. Pandas is the package that allows us to perform data analysis with Python. But what is this business of import pandas as PD? So imagine pandas is a box, and inside this box there are building blocks, various functions you can use in your software. So by saying import pandas, you tell Python, look, I'll be using building blocks from that box. Because if you don't do this, if you directly run something that is part of pandas, Python is going to say, I have no idea where to get this from. So that accounts for import pandas. Now, what is this business as PD? So this phrase, import pandas as PD, and the abbreviation of pandas as PD, this is an extremely common way of referring to pandas. Okay, so whether or not use it yourself, and I suggest that you do use the convention that everyone else is using, you need this abbreviation in order to understand other people's code. And remember, we learn by modifying already working code. So you've got to get used to how other people write code so you can benefit from their experience. So you import pandas and you call it PD. In the next line, you will see more what I mean. So you take a name. So I decided to call it main file. You can call it whatever you like, but I suggest using a descriptive name, so later on you remember what is it that you put in the name of the variable. And here is the command, PD pandas read underscore CSV, and then in single quotes the full path to the file. So read CSV. Remember, I just said that pandas was a box with building blocks in it. Read underscore CSV is one of those building blocks. Because if I don't put pandas, Python is going to say, well, what is it? I have no read CSV. What is this? So PD dot read CSV, then open parenthesis, and then single quotes, and full path to the CSV. And recall, this is the CSV here. You see, in sample data in your file system, there is this file. Okay, enter. Now, you see that nothing happened. So there's this green line and blinking cursor. When that doesn't, when nothing happens, that's usually very good news. It means you haven't made a mistake and Python did what you wanted. Well, Python did something. When we look in Variable Explorer, you see here a new line, main file. Yeah, the name I gave you. I mean, I decided main file. You can call it Irene's demo, or you can call it whatever you like, but make sure you know what you call it. The type of the item is data frame. This is the size of it, right? It has 16 columns and 1,200,000, etc., lines. Okay, and the column names. Yeah. So if you double click this, if you double click this, you can look at the file. Now, so here it is. By the way, if you go and open that CSV on Excel, Excel cannot open this. So you get a warning saying the grid is larger than what Excel is capable of opening, right? Because there's over 1 million entries. Okay, so what is data frame? Data frame, pandas call data frames what we call spreadsheets, basically a two-dimensional array of data. So, right, so here is our CSV is now inside Spyder. Let's make it more convenient for ourselves to deal with this data. Let's give it column headers. So at the moment it has this long strings, etc., etc. So it's not very convenient to use. So let's do this. Let's take column names. So let's rename columns as so. The first one is going to be ID, price, etc., etc., etc. So this is why I mentioned to you what sort of data, how that data is shaped. And then we run this command. We say, take the columns of main file and give them respectively these names. Yeah. So take the columns of the main file and give them respectively these column names. We press enter and look our main file again. So first of all, the column names is just a string, so that should be expected. But now when we look at our main file, we see column names, right? We see civilized column names, where previously we used to have sort of confusing, more confusing look. Okay, so here we're already seeing something for the second time, and let me just attract your attention to the logic of Python. When you say take something which is part of something else, let's say take B, which is part of A, take B, which is part of A, take B, which is part of A. So you express this in Pythonese as A dot B. So let's say Jack's ball is going to be Jack dot ball. Okay. And this logic carries on in a lot of things that you do with Python. And now let me also mention to you something very, very convenient. Let's say you ran some commands, and then you want to modify it slightly to correct something. So you have two options. You either recopy or repaste or retype it, or you can just press the up arrow and look, on the line appears exactly what you typed before. This is extremely convenient. This can save a lot of time, especially in the beginning, right? So you wrote something long and then you forgot a parenthesis, you forgot to close a bracket, and Python comes up with some sort of error, So you just press the up arrow, it will take you exactly to what you just ran, and then you make modifications, and you rerun it as you wish. So if you have changed your mind, you just press escape, and all of this promptly disappears. So you would be using this countless numbers of times. So please make a good note of it. Anyway, that's it. So now our data is ready for manipulation. We have our main file, and we have civilized column names. Now let's do something to it. So I live in Cambridge. So I'd like to extract from this data file all the transactions that took place in Cambridgeshire. So that is what I would like to do. To do this, I create another data file, right? So I'm going to choose some lines from the main data file, and I decided, logically, I think, to call chem file. So the logic of this command is take the main file, and from it, extract all the lines such that the county, remember one of the names of our columns here is county, so that the county of the main file, so the value of the county, the main file, contains the string Cambridgeshire. So you see this again, A of B, so the county, which is part of main file. What is this string contains? This is just, this is just an attribute. So an attribute that you can get from a string variable. Don't worry that you may not understand what it is exactly. In this particular case, make sure you understand what the command does as a whole, rather than what every single technical detail is. So let's say we run this command. Let's see what happens. So we run it, and yes, we have chem file here, and this chem file is a data frame, very good, but it has no rows. Now, this is an example to show you that common sense is alive and well. Is it possible that in an entire year, there were no real estate transaction in Cambridgeshire? No, right, it's impossible. So something has gone wrong. So what has gone wrong? This has to do with, you probably guess, capitalization of Cambridgeshire. So in this particular data set, the county is presented in all caps. So in general, in order to solve such a problem, in order to eliminate problems that have to do with capitalization, which happens a lot when you deal with data, I suggest at all times using this. So you see the beginning of this is exactly the same, but when we specify our criteria, so in the county column, it has to contain Cambridgeshire, and we switch off the case sensitivity of Python. By default, Python is case sensitive, and remember this when you are working with heterogeneous data. So you might import from several different locations. Somebody capitalizes Cambridgeshire, somebody does it in all caps, etc., etc. And if you do not switch off capitalization, you end up all caps Cambridgeshire would be something different in Python's understanding from Cambridgeshire with C capital and the remaining lowercase. That is decidedly not what you want as a data analyst, because you understand as a human being that Cambridgeshire is Cambridgeshire. So let's try again. And let's see chem file, how is it? So now it's about 15,000 transactions. Yeah, okay, that makes more sense. But notice something here. Imagine if the old version of chem file contains something valuable to you. You see how by name, it has overridden whatever there was previously in chem file. Remember, in Python, this is not equality. This is assignment. So if in Python, if you want to say equal, you have to do two equal signs. Remember this. So of course, if you after this webinar. I mean, when you go and fiddle with this, obviously there is no skin in the game. You can do what you like. You can make as many mistakes as you want. But when you work with data that is valuable, remember that, you know, if you take a variable, assign to it something, and then you take the same variable name and assign to it something else, it's going to override what's previously in there. Okay? Right. So today, so now we've got this CAM file, and those of you who love Cambridgeshire will be happy to know that in 2021 there were about 15,000 transactions. Okay, let's see now. What questions can we ask about it? Yeah. First of all, let's do something about which Sonia asked last time. So now you have seen how to take a CSV file and how to bring it into Python, you know, so let's see, can we take a CSV file and get it out? I mean, what if we want to open this CAM file with Excel? Can we do it? No, right? So, you know, this is still some, you know, variable inside Python. Can we turn it into something that Excel can open? And well, absolutely. Here we go. So you take CAM file dot to CSV. So the to CSV is a function, and I have chosen in this case to create a CSV with the name pp 2021 underscore CAM. Again, no responses from Python, so good news. So hopefully nothing has gone wrong. Now, how do I check this? So I go into files, because remember, files is the most ordinary file system in Windows. And now I see that in sample data, there is pp 2021 CAM CSV. Just so you believe me, let me just show you that you know, here we go. So this is an ordinary view of Windows file system. Okay, so this is the most ordinary PowerPoint, the CSV, and this is another CSV. If I want to open it with Excel, I can, well, eventually. Okay, 1 second, let me show you that. Can you see Excel? Yeah. Okay, so there it is, the PP 2021 CAM. So just to show you that, you know, I'm not playing tricks on you, that this two-way transfer of data is you know, possible and very easy. Okay, right. Now back to my initial okay, can you see, are we back to the black screen, Sonia? Yeah, okay. Very good. So yeah, CAM file. But 15,000 transactions are still too many. Let's see this. Let's extract from it. Let's extract from it, let's say all the transactions that happened in November of 2021. Now, in order to see how to do it, and if we look at our file, this is the format in which data is rendered. And I want to render it, and I want to use data as the most ordinary string. So year, month, date. So I want to be slightly clever and say this. Create a new data frame, so a spreadsheet-like object, extract from CAM file all of the things where the date column contains this. Now, I've shown you the file. If it contains 11 dash. Yeah. So what can go wrong? 2021 is 2021. I mean, 11, there's not going to be a mistake because of this, but there might be a mistake if something occurred on the 11th of some month versus something that occurred in the 11th month. And by choosing 11 and using the dash before, afterwards, I eliminate that mistake. Okay, that's slightly smarty pants, I agree. But look, I'm just saying life is a mixture of all sorts of different things. So if you do this, we now have, predictably, another data frame, Cam November, 900 items, 901 item, yeah, out of these nearly 15,000 that happened in November. Let's see what other ways we can fiddle with. Here. What about finding out what properties change hands in a specific postcode? Let's try that. So again, we're still in Cambridgeshire. So I want to create this kind of data frame. Extract from CAM file all the entries, such as the postcode, the postcode column contains CB1 something. And again, look at the format in which postcode is written. Yeah, 3 characters, then, space, and then the remaining. So I want CB1, 1AD, etc., etc., etc. Okay, and note, by the way, so how little we work with this string contains. You can see that this is just a standard way of saying something, which tells you that there is no need when you are just starting off to understand in detail how it's built. All you need is to understand what the overall statement does. Because when you know more, you might have an occasion to find out more about these internal things. But in the beginning, if you start going off on tangents, that is going to confuse you a lot, because a lot of effort, a lot of decision-making has come together to make Python comfortable and usable by a lot of people today. Previously, it was extremely technical, only coders can do it. Okay, so there we go, enter. But look, now Python is very unhappy. And you have value error, whatever that is, cannot mask with non-Boolean array containing and etc., etc. Now, if you are in the business of real estate, you have probably already guessed what is going on. I mean, all properties that have changed hands, all properties in Cambridgeshire, among these things could be ordinary plots of land, which don't have postcodes assigned. I mean, because postcode is a, not every square inch in UK is by default assigned a postcode. So what happened is when this in the government CSV, in the postcode cell, there is nothing. Let's say if it's a land plot, there is nothing. When this CSV comes into Python, Python assigns to it a value, the NaN number, to indicate that this is something that doesn't have value. But when we try, running searches with a data set that potentially has empty this NaN values, then you get objections from Python. And again, there is a very standard way that I can highly recommend to you to use this. So okay, so what you do is change it in this way. So the beginning is exactly the same. The string contains this, because that part is not where we made a mistake. But here we'd say, and it's not empty. Okay, so the search of finding this postcode is to be conducted among places that have postcode to begin with. Okay, so if you were to say this phrase in an ordinary language, that's all that is mean, because so you have to exclude things that do not have postcode assigned to them. So when we do that, no objections from Python, and here we go. And if we open it, well, Yeah, that is properties that were sort of changed hands in 2021, and we got various places in CB1, whatever. Good. Let's see. Maybe Sonia, is it okay to do a small one with plotting or with overrun? Because I think.
Yeah, we are running out of time, Irene, so I think we should wrap up. And if we have any questions from the students, what else are you showing to the students?
Well, I mean, I wanted to show you the plotting, because and mostly because last time you asked about plotting.
Yeah.
Okay.
Let's do that, and then we can wrap up. And then if they have any questions, I mean, if they don't mind to stay a little bit longer, it's fine. I have time, so we can have
Can you
another
ask
10
them,
minutes.
because maybe somebody has a meeting to go to and they are sort of, is it okay?
Yeah, I mean, I'm happy we can run this until for 10 more minutes. It's fine, Irene. So let's just go ahead.
Okay, yeah. So in this case, let me see. Let me just very briefly show plotting, because last time I remember there was a question about plotting, and I don't want to sort of leave you hanging on this important subject. Plotting. In order to plot something, we need to import the pyplot library, which is part of matplotlib. And the standard way of importing that, the standard abbreviation for pyplot is PLT. So if you're reading someone's code, you see PLT, that's pyplot. And pyplot is part of matplotlib. Yet again, you see this logic. A that belongs to B. See, something dot something. The next step is to define the size of the figure. And why is that? So by default, if I didn't put this, okay, so if I put a hash in front of this, it would be grayed out, it would become a comment. Remember, this is also an extremely, extremely useful way of switching off parts of your code. You put hash in front of it, and it becomes a comment. And Python knows that it's not going to run this, because when you are troubleshooting something, you're trying to switch off bits and trying to work out where is the mistake happening. Sometimes it's very important to be able to switch off things locally. Okay, so if we switch off that and run this, oh no, well, yeah, sorry. Sorry, there we go. See what I just did? I made a mistake. Python said, oh, what is this? I don't know. I just pressed the up arrow. Everything came back again, and I quickly edited it. See, this is the beauty of the upward arrow. Okay, so here it is. So it says, well, so if I click on plots, I will see this. When I click on files, I see there is something called camplot, and it looks like this. And here is where the problem lies with this camplot. If you don't specify the size of the plot, the pyplot shows you, the default sizing is 6.4 by 4.8 inches. Okay, so now, and I mean, I'm unhappy with this. I mean, I want a much more larger plot. So this is why I uncomment this. Okay, so now this becomes a live instruction to Python. And let's do it again. So again, and look how much better this plot looks. So now the plot looks like this. You see? So much more can be seen. It's larger. Previously, it was all squashed together and rather inconvenient. So this business of specifying the size of plot, I think it's rather relevant. So it's not a luxury; it's a necessity. Yeah, that's pretty much it. I think if I talk much more, people will start falling asleep or going to I don't know, leaving. So that's pretty much it. As I said, whatever I use today, I'm going to put on a text file and let Sonia have the text file so you can see what's been said today, what sort of commands have been run today. You can go create your account at land registry and download the data. You can see that you have absolutely everything in your hands to starting working with Python right now today. As you can see, nothing extraordinary happens. Don't take things too seriously, just go one step at a time. And remember one very important thing: whenever you can, modify working code that exists already. So first, find a piece of code where you know what it does already, and modify it in places that you think you think are reliable, and run the code in this way. So to start with, it would save you a huge amount of time and effort and frustration. It would allow you to become productive in your company immediately. Because we are not children, we don't have 6 years to learn something. We are expected to become productive in our environment immediately. And at the same time, once you have a large enough bank of statements that you know what they do, imperceptibly, there comes a moment when you find it much quicker to type the command, much quicker to create your own, because you attain the mastery and you realize that, oh, no, copying pasting is slower than typing it myself. But this happens painlessly for you, rather than you being stressed. Oh, did I put parentheses right? Did I put a full stop right? Python gives some bizarre error code. What does this error code mean in a human language? So in order to sidestep this, because all of these diversions, they cost us time, and in a business environment, the most important thing is the analyst's time. It's not the machines, because the machines next year, they are going to be 10 times faster. So in order to save your time, get into the habit of collecting lines of code that you understand exactly how to use. And when you need to create something, simply assemble stuff out of them. When somebody sends you a script and you run a script, look at the script with your eyes and, make sure you roughly understand what is going on. And later on, when you need something similar to that, just comment out whatever you don't need, whatever features you don't need from that script, and run it, to obtain the functionality that you need. So basically, programming is the lazy person's game. Don't be too hardworking, because in this case, you will suffer as a result.